Okay, this video is going to be on how to graph parabolas. So first, this is just the general parabola vocabulary. The focus here is the point that lies on the axis of symmetry of the parabola. The vertex lies halfway between the focus and the directrix line. The directrix is perpendicular to the axis of symmetry. What's very important from here is that when we find our focus point, it's going to help us draw our parabolas at the focus and any distance to the parabola. This distance is always congruent to the distance from the parabola then to the directrix. So if you think about this kind of as a box here, this distance here is always congruent to this distance there, and this distance here is always congruent to this distance here. And then we have the vertex of the parabola that centers the parabola, and it is symmetric on either side of that vertex then. So it's going to be similar to the parabolas you've seen before. We will have the y equals parabola where our leading coefficient is positive, it will open up. And when we have a y equals parabola with a leading coefficient that's negative, it opens down. The one difference is that the equation this time is y equals 1 over 4p x squared. Opening up if the 1 over 4p is positive, and y equals negative 1 over 4p x squared is our equation we're going to use if the negative 1 over 4p, then it opens down. The p in this is very important. So the 1 over 4p and p we'll have to solve for. The p is going to be the distance from the vertex to the focus, and it's going to be the distance from the vertex to the directrix line. So p is going to be a very important value that we'll need to find when we're graphing this. Same here, the p value is going to be from the vertex to the focus, that distance, and then from the vertex to the directrix line is going to be our p value. This is new here, we have x equals. Instead, our x equals 1 over 4p y squared. And then we have x equals negative 1 over 4p y squared. So if it's an x equals parabola, it'll open along the x-axis. And then remember, the x values are positive over here, so if it's positive 1 over 4p, the parabola will open to the right. The x values are negative to the left side of the x-axis, so if you have negative 1 over 4p, the parabola will open to the left. The p value in these equations is going to be the distance from the vertex to the focus, and again, the distance from the vertex to the directrix line. So the p value is defined the same way. It's always a distance from the vertex to the focus and a distance from the vertex to the directrix. Remember, distance is always positive, but we'll go one to the right and one to the left on either side of the vertex. So here's our first example. This is a y equals, so it will open along the y-axis, and since it's a positive leading coefficient, it will be opening up. So our general form of this parabola would be 1 over 4p x squared. Our vertex in these parabolas is going to be centered at 0, 0. We have not shifted these parabolas at all. There is no h or k value. All of the vertexes in this notes will be centered at 0, 0. In order to find our focus, we need to solve for our p value. So 1 over 4p from our general equation in this equation is equal to 1/8. So we're going to set 1 over 4p equal to 1 over 8 and solve for p. So in this example, you can kind of use mental math and say 4 times p has to equal 8. Well, p has to be 2. You can cross multiply, and so 4p times 1 equals 1 times 8, and then solve this equation for p. Either way, p equals 2. Since it opens up, your focus is always in the center of your parabola, and the directrix is always behind the parabola, or under it, I say, or above it. So p gives us the distance from the center to the focus, and it's 2, so we go 2 above. Then it's also the distance from the center of the vertex to the directrix, so that will be down here. So the focus will be on a y coordinate, 0, positive 2. The directrix is always either a horizontal or a vertical line. It must be written as an equation of a line. It goes through the y-axis, so it will be y equals, and it crosses at negative 2. So y equals negative 2. Then to help me draw this parabola to scale, I noticed that this distance here from the focus to the directrix is a distance of 4. So that means that I have to go 1, 2, 3, 4 this way, because these distances from here to here always need to be congruent. And that just gives me an idea of outline of how to draw this parabola, because here's the vertex, and it needs to be about that wide and about that wide. So that's our first example. Okay, the first thing I notice about this example is that it's not written in standard form. It either needs to be in the form y equals 1 over 4p x squared, or x equals, plus or minus, really, plus or minus 1 over 4p y squared. So I notice that I have just a y, and then my x squared is my squared term, so it's going to be one of these equations, which means I have to use inverse operations because I want to solve just for y. So to do that, I'm going to start by adding x squared to each side. I get negative 28y equals x squared. Then to get y by itself, you'll have to divide by negative 28 on both sides. And I want to write it as 1 over 4p. So this is, remember, has an implied coefficient of 1. So 1 over negative 28 x squared. So this parabola has a vertex of 0, 0 again. There's no hk value with the y or with the x, so the vertex is 0, 0. Again, since it's y equals, it will be opening along the y-axis, but this time, since it is a negative y, it's a negative 1 over 4p, it will be opening down. That means the focus will be along the negative y-axis, and the directrix will be a vertical line up here. To find the focus, you need to find the p-value. So this time you have the 1 over 4a is negative 1 over 28. Since p is just a distance, you don't have to worry about the negative. You just need to find what is p. So again, this one you can solve with mental math. 4 times 7 is 28. So p is 7. That means that since it opens up and down, the vertex will be, the focus will be 7, 1, 2, 3, 4, 5, 6, away from the center, and the directrix will be 7 away from the center, the vertex as well. Just a quick outline of how to graph this is a distance of 14. So you would have to go over 14 about, and then back 14. So this is going to be off my graph. This parabola is going to be extremely wide. So my best sketch is probably going to look something like this. This distance is very large, which tells me that it's going to be very wide. The closer it is, the closer the focus is to the center, the more narrow the parabola will be. Remember when we talked about a value, the smaller the a value, the wider the parabola. This fraction is extremely small, so it will be very, very wide. The focus is this point, which is going to be the point 0, negative 7. The directrix is this vertical line, which is going to be the line y equals 7. All right, this example is in standard form. It's x equals though, and it's negative 1 over 4p, so this means that it opens along the x-axis and it will open to the left because it's negative, and the negative x values are over here. Again, we have a vertex at 0, 0. This time our 1 over 6 equals our 1 over 4p. So I can't do this mentally because I don't know 4 times what equals 6. So I have to use cross multiplication. 6 times 1 is 6. 4p times 1 is 4p. Divide by 4, I get 3 halves equals p, or 1 1/2. So it opens to the left and right, and it opens to the left. So 1.5 will be my focus on the x here, and I go to the left 1.5, that will be my directrix. So the focus will be at the point -3/2, 0, and the directrix this time has a vertical line that goes through the x-axis, so it will be x equals 3/2. To help me sketch this picture accurately, this is a distance of 3, so I need to go a distance of 3 here, so that this distance is congruent to this distance, and this distance is congruent to this distance. So that gives me a parabola with a vertex at 0, 0. That will look roughly like that. This one, again, was already in standard form. All right. The last example for graphing, it needs to be written in standard form. So first you'll have to solve for x. So this one will be x equals 1/20y squared. It will be opening to the right this time. It'll have a vertex of 0, 0. P value 1/4p equals 1/20. So p in this case will be 5, since 5 times 4 is 20. Which would be 5 to the right, and the directrix will be 5 to the left. The focus then will be the point 5, 0, and the directrix will be x equals -5. This has a distance of 10 in between, so we have to go 10 to the right and 10 down. That's just to give us a nice, accurate sketch of this wide parabola. I went through that kind of quickly. My video only gives me 15 minutes. I'm at 12, so I'm going to go to one of these examples first. So I have a vertex at 0, 0. The focus is at 0, -9. That means my focus is on my y-axis. I'm going to sketch a quick picture of this. If my focus is down here, that means my parabola is going to be opening down. So my general equation would be y equals -1/4p x squared, where p is the distance from the center to the foci. In this case, from 0 to -9 would be a distance of 9. So plugging 9 into for p, my equation would be -1/36 x squared. This example is very similar, except for that my focus is at the x-axis at -4. My center would be 0, 0, so it's opening this way. So this time it's going to be left, so -1/4p y squared, where p is this distance, which from 0 to -4 would be 4. So x equals, plug in 4 there, you get -1/16 y squared. If they give you the directrix, essentially it's the same thing. Sketch your picture. The directrix at y equals -3 means that the parabola opens up this time. And then the p value is still the distance from the center or the vertex to the directrix would be a distance of 3. That equals your p value. This opens up, so it's going to have the general formula of +1/4p x squared, where p is 3, so it will be y equals 1/12 x squared. And the directrix then of x equals 6, +6, the directrix is that vertical line. It would be centered at 0 still, so it's going to be opening to the left, which means it's going to be a -1/4p since it opens to the left. If it opened to the right, it would be +1/4p y squared. P is the distance from the center to the directrix, which is going to be from 0 to 6 is 6. So if we plugged in 6 for p here, be x equals -1/24y squared. I went kind of quickly through the last couple examples because I was running out of time. But remember, you can always pause the video and go back and work through it and watch it over. So if you have any questions, let us know. Thanks for your time. Good luck.